Welcome everybody to the third in our series of Refinitiv Developer Community webinars. Today we'll be taking a look at how to build data-rich interactive financial applications with streaming content from the Refinitiv data platform. And we'll see how WebSockets and new frameworks are making it easier than ever to achieve results rapidly. There will be live code and examples. My name is Toby Amis. I'm the head of developer workflows in the platform advocacy function here at Refinitiv. We're aiming to make these events as engaging and interactive as possible. So we'll be asking a series of poll questions throughout to gauge your preferences, interests, etc. And of course, there is a submit questions feature on the platform we're using at the toolbar at the bottom. In terms of that toolbar at the bottom, you can ask questions. You can look at the various different options available to you. There's the speaker bios. And we'll look to answer as many of the questions throughout the session as we can, as well as the polls, to make sure we keep on top of that. So do please feel free, and we'd encourage you to ask any questions as you anything that piques your interest within the presentations. And of course, there is a resource list with the ability to register for our future events. This is the third in a series of 8 throughout July and August, with many more to come in the future. And in fact, we'll start off with a question now. It would be great to know where you're joining from. What I'll do is I'll ask these poll questions, and we'll revisit these questions at some point as we step through. Now, before we do that, what I want to do is give a little bit of context to the people who are presenting, and also to the Refinitiv data platform itself. So let's move on and introduce my colleagues and presenters on today's topic. Umer, Nalla and Gurpreet, colleagues in the platform advocacy team. Umer's joining us from London and Gurpreet from Toronto. Now, Umer has worked in API consultancy and development with many of our largest customers for many years, really from tier ones through to boutique shops, and including working really closely with market data teams. His primary focus has always been real-time streaming data, and that's broadening more now to include our platform offerings. Similarly, in many ways, Gurpreet has been with the company for 19 years, actually, mostly in professional services and helping their clients with his solutions, but often in the real-time streaming space as well, and again in the data platform more recently. So very well versed in the major programming languages and most common systems and web technologies. Now, what I'm going to do is just have a quick look at where we've got the polling from, and then I'm going to literally spend 2 or 3 minutes giving you a little bit of context as to what the Refinitiv data platform is. We'll be focusing in on the real-time elements of that platform, but I just want to give you a little bit of an understanding of where that platform sits within the overall priority. Before we do that, let's have a quick look at where people are dialing in from. We've got 24% UK, 23% USA, 9% Canada, going down Italy, Brazil, South Africa, India, Mexico, Switzerland, and 21% somewhere else. Apologies if we didn't get your country into that list. Okay, so without further ado, let's have a little look at what the Refinitiv data platform actually is. So, as it stands today, many of our customers will be used to using a wide variety of APIs and products that Refinitiv go to market with today, particularly in the enterprise space. We can see a representation of those products today. Now, often those products go to market with different technologies, different endpoints, and it's not always been as simple as we would like to make it for our customers to gain access to the fantastic content that we have. And so a situation, as you see developing here on the screen, in terms of our platform or our enterprise APIs, which was complemented on the other side here, we can see ICOM, which is our desktop offering, which uses COM and .NET and other things as well. So you can see, whilst the content is fantastic, it's not always as straightforward as we would like to make it. in the world of the Refinitiv data platform, things take on a far more simple, less complex, easy to use manner on a number of different levels. First of all, we have a layer of analytics running across that platform. So if we consider the platform has all of our data assets within it, we also have then a layer of analytics for producing bond curves or zero curves or other instrument pricing analytics or quantitative pricing analytics that we may, our customers demand from us. And underneath that, we're supporting that with a far simpler technology stack of JSON and RESTful APIs for the non-streaming side and WebSockets for the streaming side of that equation. And if we then bring into touch away from the platform, but a part of the platform, the human interface to the platform, then we have our icon and our new strategic desktop solution, Refinitiv Workspace, equally using the same WebSockets and JSON calls. So in the not too distant future, we will get to the stage where we have similar syntax, similar data sets, in fact, the exact same data sets on both the Refinitiv data platform and available within our desktop solutions, which mean that lift and shift from a desktop to enterprise becomes far, far more straightforward. Now, I'm going to hand over to Umer, who is going to touch on some of the different functional layers and ease of use around the Refinitiv data platform. And after that, I'm going to come back with another poll question. So, Umer, welcome. Thanks for joining us. And over to you to touch on this slide before we ask a couple of questions and go into your demo.
Right. Thank you, Toby. So in Toby's slides, he talks about the raw WebSocket and the RESTful interface. And the first couple of the demos that my colleague Gurpreet is going to be doing will be using those raw interfaces. However, for my demos, I'll be using the Refinitiv Data Platform Library. So what exactly is the Data Platform Library? Well, it's an ease of use wrapper built around the WebSocket, the REST API, the raw interfaces, which you can use if required to make your life easier for yourself. And if you're using one of the supported languages, then it makes a lot of sense to do so. So the key benefits and features of the platform library are, well, firstly, it's going to be available in Python and .NET versions as well as TypeScript. So the Python and .NET version are currently available in like alpha/beta release, and the TypeScript version is to follow quite soon. Okay, now the other key benefit is that the single library can target 3 different delivery platforms. So you can use a single library to connect to the desktop. In other words, if you're running Icon or Refinitiv Workspace on your desktop, you can use a library to connect to that and consume data from that. Or if you've got deployed servers in your organization, like a TREP server, you can connect to that using a library. And finally, you can always use a library to actually connect to the platform, in other words, the cloud as well, all from the single library. So the idea is that within a single application, you can open up all 3 sessions if you wanted to. But the more realistic scenario probably is going to be where you might prototype, say, against your Icon desktop or your Refinitiv Workspace, and then once you're kind of happy with your proof of concept and you want to roll it out into your organization, you can change a single line of code, retarget the application towards the cloud, and create a platform session, as it were, and then consume your data from the actual cloud itself. Okay, the other key benefit is that we offer 3 abstraction layers. So we have the easiest to use, which is a function layer. Now, this is typically trying to replicate Excel functions. So it's like a single line synchronous call, like e.g., get me historical data for so-and-so Rick, and you wait for the response and you get a data frame or something back. Then we also have a content layer, which lets you access the same data you can access with a function layer. In addition to that, it lets you access streaming market price data as well as things like chains. So if you want to subscribe to a particular index and get a real-time updates for all the constituents of that index, you can do that using the chain object. And the other key benefit of the actual the content layer is the fact that it gives you much more flexibility in terms of you can do, as well as a synchronous mode, you can do event-driven asynchronous calls depending on your usage requirements. And finally, we have the delivery layer, which is a layer that is used to implement the 2 high-level layers, but you can also use it if you want to access things like level 2 order books and maybe other types of content which aren't currently supported by the function and content layer. Okay, so we're going to I think we're going to have a survey now. But after that, we're going to jump into some demos on code. So I'm going to pass over to my colleague Gurpreet, who's going to be using the raw APIs, after which I'll do some demos using this Refinitiv Data Platform library itself. Okay, thank you.
Thank you, Umer. Before we launch into Gurpreet, and welcome Gurpreet, thanks for joining us. We're interested to know what role best describes you, audience. So Gurpreet, please move forward and we'll come on to the result of that poll in due course. Welcome.
Thank you, Toby. I'm going to begin by sharing my screen. My demo is going to be based on how to display streaming market data in a web page. So let me just share my screen first. Should be coming up shortly.
I see you now.
Okay, thank you. So this is what we are aiming for in this first demonstration. Basically, just build an interactive widget with streaming, real-time streaming market data. So this quote with the changing prices that you see over here is a real-time quote for Apple, and it's being displayed in this Chrome browser page. By the way of code, it's going to be hard to look into the code step by step as to see what's really happening. So what I'm going to do is basically walk through some block diagrams and show you the underlying protocol that's used to build this. And the sample, the whole complete working sample is available on our Refinitiv API samples GitHub site, links to which will be provided to you all. So you'll be free to download it and try it on your own time. So what's happening in this page, let me close this code window, is that we have a browser over here, a web browser, and it starts off by making an authentication request to a Refinitiv data platform. Authentication request is required because you need to get an access token. That token will give you the access to the real-time data, both streaming and non-streaming. Fundamental type of data could be non-streaming. So the first step is get an access token. And after getting an access token, another REST request is made to RDP. And this one is to get the endpoint for the streaming service. The streaming services endpoints are distributed geographically all over the world. So depending on the region closest to you, you could pick one. And once you have the endpoint and the access token, both of them, the browser uses the WebSocket protocol, which is built into the browsers, to connect to that endpoint and use that authentication token to perform a login request. After successfully logging in, you send in another JSON message on the same WebSocket protocol, specifying the domain as market price, which is level 1 tick-by-tick data. And outcomes is a response. Response is all the response from the WebSocket is in JSON. Basically, it's a type refresh and contains a whole bunch of fields with updates consecutively following the initial refresh image. So let's take a brief look at this JSON protocol that's happening on the WebSockets itself. So the login request, you specify that this is basically, once the WebSocket has been established, everything that's happening on that WebSocket is plain JSON itself. For the ERT in cloud, this is a secure WebSocket, so it's going over the secure channel, and it's all encrypted end-to-end between your browser and the ERT cloud ADS server. So the login request, you specify your application position and your access token, and if the login is accepted, you get a login accepted response, which provides you some basic fundamental data about what kind of channel and how much you're allowed to subscribe to it. Followed by that, you do an item request, give it a unique identifier for your item. This identifier can be used in future to close this item or something else. And the item response is a bunch of fields. And the item type, if you go look at the bottom, is of type refresh. And after the initial refresh, you can get any number of item updates, which is the deltas from the previous refresh message. So how is it happening in the browser level? So I'm just going to open up the console, debugging console on my Chrome here and start a very simple console example. So everything is happening in the code itself. Nothing is being shown in the browser. So what happens is initially we go and get a token. And after getting a token, getting the pricing endpoint, we initiate a WebSocket request to ERT Cloud server. And this is one of the endpoints that we've picked in the code because it's closest to me here. And if you look at the network tab, after getting the whole bunch of HTMLs, what the browser did is it started this WebSocket connection here. And the WebSocket connection, it begins from a login, passing in its authorization token. And after it got a successful login response, we started subscription to EOR equals. And all the update messages that I see over here That's the FX rig for USD conversion rate. And you can see the various data feeds that are being carried in this. The payload is all JSON in text. And once you have this, basically it's up to the application to either use another library to help render it the way we'll see next, or just use the raw DOM, pick out the values from the JSON and just plug them into the DOM itself. So we've already seen the code example, but let's take a look at it again. Here we are authenticating with EDP, RDP now, and requested marketplace data for Apple. And similarly to this, if we look at the news widget, so here we're using the exact same library that we're using for the WebSockets, and instead requesting for news. This is a news headline that are flowing in, and this is a news story associated with it. So very briefly touch base on the code. So, sorry, not this one. So this is a code example. Everything is abstracted into libraries. You could use those libraries in your own code itself. So we use the EDP controller and get an access token from it, passing in your username, password, and client ID, which is the application ID. And once the status change login response has been received, we initiate a market data request here. In the controller itself, WebSocket controller, going down, we just start a new WebSocket. And the server and the port is what we received from the REST API call. And on open and on message, whenever on open is received, which means the WebSocket has successfully established a connection, we send in a login request and we pass those login messages in the on message, which is we subscribe to the market data. For the code application itself, we are using AngularJS in this particular demo. So this is this code widget. I'm showing you the code for this code widget. We're using the ng controller widget as code. And if you look at the source code for this code object, basically using ng animate. So library is basically doing the heavy lifting of rendering the whole thing on the web page for us. And just like the ERT controller we saw earlier, once the ERT controller is set, we get an access token and connect to the ERT and pass in the login message. So that's basically what the demo is.
Thanks, Gurpreet. Let me just get the polling back on the roles that we see. So we've got, a high percentage developers, which we'd expect, very interesting and in line with our own thinking. Traders, researchers, CEO, decision makers, quant data scientists. This is a fantastic spread of people. So we're really delighted to be reaching this audience. Let's go on to just one more poll question, then we'll pass over to you, Umer, to touch base on your demo. Are you part of the developer community at Refinitiv today? We have a ton of articles really pivoting towards workflow-based articles these days. So very interested to know if you're benefiting from that already. Of course, there's all the existing information, samples, tutorials, videos, and information, of course, all about our webinars and recordings are on there as well. So let's pause on that one. And I think we're over to you now, Umer.
Oh, thank you, Toby. Just before I move on to mine, I just had a quick question I wanted to ask Gurpreet. So you mentioned Angular, I think, a couple of times. Is that the only framework that can be used with a WebSocket, or is there other frameworks? So I'm not a JavaScript person, so, just wanted to throw that out to you.
Yeah, so Angular is just one of the frameworks. I mean, you could use React.js or Backbone if that's what you're already using in your organization. But if you are not a frameworks person, I mean, it's pretty easy to just pluck those values out from the JSON message on the WebSocket and just inject them into your DOM, in the browser DOM.
Okay, excellent. Thank you. Okay, so I'm just going to do my demonstration. I'm just going to start with a screen share. Okay, I'll give that going. Right, so... Sorry?
Whilst we pause for that screen share to come on, let's just quickly look at this poll. Are you a part of the developer community Refinitiv today? Yes, 36%. Interestingly, a third of those are not. So a great opportunity for us to encourage people to join that community. Lots of great things we can do there. Let's just ask another question. Are you interested in displaying market data in a web page? And we'll pause and let you answer that whilst Umer continues. Thanks, Umer.
Okay, thanks, Toby. Okay, so as I mentioned, Gurpreet talks about using the WebSocket API, which is the raw interface, and I'm going to be using the Refinitiv Data Platform Library, which is the ease of use layer, which is around the WebSocket and the REST APIs. And obviously, I'm going to kind of be demonstrating some GUI stuff as well. So earlier this year, I had to plot some charts for some articles I was writing for a technical analysis article, and I also had to do some volatility surfaces and curves and so on for some articles for our developer portal. So whilst I was researching which library or visualization framework to use, I found a lot of examples online that consume, say, some historical market price data and just plot it. But I barely came across any examples that presented any real-time ticking data. So, actually the charts were updating in real time as the market price changed. So at that time, I just made a mental note saying, okay, I'll have to look into this, because it must be an interesting way to do this. So anyway, fast forward a couple of months, and today I'm going to be presenting, 3 simple use cases of streaming data with Python-based interactive charting and/or visualization libraries. So namely, I'm going to use Dashplotly, Matplotlib, and IPyWidgets, and all of them are based using the Python version of our data platform library. So I'm just going to start up my Dash example because it takes a few moments for the actual Dash server to start up. So I'll just kick that off. Okay, so I'm going to start with Dash from Plotly, which seems to be one of the most popular frameworks out there for data science apps. So now I have to point out to you that I'm a complete Dash newbie. I've not really used it before. I had presented a couple of Dash examples last year during our Developer Day series, but they'd actually been written for me by some of my colleagues, including Gurpreet, for me to actually present during the series of events we had. So this was the first time I'd actually tried to use Dash myself, and I found it relatively easy to use. And I've also tried to keep the examples simple as possible as well, because I just want to give you a kind of flavor of what is possible in terms of using streaming data with the Dash framework. So I think we've got the server running now, so I'm just going to kick that off. Okay, so at the top of the screen here, I'm just getting some interesting errors here with the actual Dash framework. There seems to be some known issue with the Dash framework. I Googled it, and there's a few people kind of reporting that. But if you give it a few moments, it should catch up with itself. And okay, that is fine. Okay, so at the top here, I've got my drop-down list where I've just populated with a few instruments. I've got the euro, I've got the Swiss franc, a couple of equity RICs as well, British Petroleum, and so on from the LSE. And so obviously you can click on that and choose an instrument. Below that, I've got my streaming graph. So this is using the Dash streaming graph. Now, what I've done for this is I've actually, on startup or when somebody selects an instrument from the drop-down list, I actually do a get historical request to request the 200 historical ticks for that instrument. So I can use that to backfill the actual chart. And then after that, I open up a streaming request for the selected instrument. So in this case, we've got the euro. And as the ticks arrive from the server, I start plotting them onto the end of the chart on this side to kind of give you a visual indication of the tick prices it's ticking along. As you can see, it's ticking up there slightly. Then below that, we've got a Dash table. And all I'm doing in there is just picking up a few select fields from for the euro instrument and just displaying them in the table. So we've got the open price, historical close. We've got the bid and ask price here as well. And as well as the mid price on the right-hand side, which is the price we're actually plotting on this chart, the mid price. Now, if you notice, the bid and ask sides are actually blank. That's because I'm using a currency RIC, and obviously there's no bid and ask size for that. So if I try changing that to, say, British Petroleum, give it a few moments for it to catch up. There we go. So now we can see we've got the chart for BP. So I've gone and done the historical request for BP, and now I'm plotting the incoming ticks as well. So we can look at the data table now. We can see there's a bid size and ask size, as well as a trade price and trade time for British Petroleum. Now below that, I've got another Dash table, another streaming one where I'm actually requesting streaming news. And I'm showing the headline here in this column, as well as the PNAT code, which is the code you would use if you're interested in requesting the actual full story behind that headline, as well as some codes related to the actual story itself. Now, below that, I've got a non-streaming example as well. So I know this is meant to be a streaming example, but I just want to make the point that the data platform library is not exclusive for streaming data. You can use it to access, a vast array of, different kinds of reference data, analytics, surface data, bonds, financial contracts. So here in this example, I've picked environmental, social, and governance data. So we've got the last 3 years of ESG standard scores for Vodafone, and I've just kind of populated the table with the various scores with the headings and so on. Okay, so that's pretty much the actual demo of the example. So I'll now go and look at the source code, a little bit of a code walk through the source code. Just bear with me.
Let's just answer the next poll question as well, Umer. So we asked, are you interested in displaying market data in a web page? Nearly 60% yes, streaming prices. Another 23, nearly 24% is yes, snapshot only, and 17% no. There is a couple of questions come in on the Q&A form as well. Let's touch on those. Manmeet has asked, can real-time libraries be called on server side? I think I know the answer to that, but Umer, I'll let you give us the benefit of your.
If you've got a data platform license as opposed to a desktop license, if you've actually got a license for the data platform and not just an icon license, then yes, you can write an application using the library and run that as a server application. That's not a problem. I mean, there may be some restrictions in terms of the data with the licensing, in terms of whether you can redistribute the data or not downstream, but that's not a technical issue. It's more of a licensing issue. Yeah. Is there anything you want to add to that, Toby?
No, that's good. Exactly. I just want to make you to keep me honest here. So we've got Jonathan who's come in with a question. Jonathan Van Der. I move that. I can't move my column, so it's a longer name. Would you recommend using Django in combination with your WebSocket API? Do you have any experience of that with Umer and Gurpreet?
I'll leave that with Gurpreet, I think.
Sorry, Umer. Django
no, I'll leave that for you to answer, I think.
Yeah, Django can be used with the WebSockets API as well. Django has a WebSockets module, but I'm just searching the developers portal to see if we already have an existing sample. It doesn't look like we have a sample, so what we'll do is we'll write up a sample and put it in there for future users.
That's great, Gurpreet. And we've also got Jorge Norina here is asking if we've got the Dash streaming notebook available as a sample. Absolutely available on the dev portal on GitHub at the moment, and there'll be articles. There's articles around as well on the dev portal. And as Gurpreet says, we're very interested in working with any of you on use cases or helping to discover the sort of power of the APIs and what you can do with the content. So very keen to hear from anybody who wants us to work on any other examples. Just before you carry on, Umer, let's just ask one more poll question. Are you using WebSockets for real-time pricing? And then I'll back over to you, Umer, to continue with your next example or the code.
Okay, so this is the code. We're going back to look at the code just to refresh your memories. We've got the drop-down list there, the streaming table here, a dash table with the streaming fields, the news table, and the ESG data there's at the bottom. So just so you can reference that when we go through the code. So fairly straightforward, this code. I'm just pulling in my libraries here. So the Dash and Plotly libraries, and I've got my data platform library as well. It's a few variables here with a list of RICs that I've been using to populate the drop-down list, and there's some of the fields I'm using in the actual Dash table for the streaming fields. And then I've got my tick field here, which is a field I'm using to to request the historical data for the actual chart, and then also the real-time tick that comes in. I'm using that to plot the actual chart. So that's the mid-price field here. Okay, finally below that I've got the news RIC, which is a RIC I use to request a streaming news data. And the selection of fields I'm actually extracting from the streaming news data. So we've got the PNAT code, the headline, and the news codes. Okay, so now below that, I've got my get data method. Now, this is the main method I'm using to request my streaming and non-streaming data. The first time it's run, so when the application is started up, and also when somebody clicks on the drop-down list, this method gets run. Now, the first time it's run, we have the initial run flag set to true. And what that means is on the first run, I'll get the ESG data in because I'm not actually updating that each time. It's just some static data. So I'm just calling a function from the function layer, which is get ESG standard scores for the instrument. And that's returned as a data frame. And then, again, on the initial run, I'm creating my streaming news request. So I'm using the streaming prices object, which is a content layer object, passing in my news RIC and the fields I'm interested in. And I'm saying streaming news open. That sends a streaming news request off to the server. Then what happens is the server will respond with the actual real-time news stories, and the library will start caching the news stories behind the scene. And if I want to get hold of that data in a synchronous way, I can just call get snapshot to get hold of the latest news story. Okay, below that, so they've got the code which is run every time this method's called. So even whenever somebody selects a new instance, this is a function from the function layer. So I'm saying I want the mid-price field, and I want 200 RICs in the past from this point back for the actual RIC that's been selected, and then I'm just converting that to a list. And then we've got the streaming price request for the same instrument, and the selection of the fields we had here, so things like the bid size, ask size, and so on. And then again, I send my request off to the server by calling streaming price open. The library starts receiving responses from the server. It starts caching them behind the scenes. I can then call upon them when I want. Then on from that, this is the actual code that I then run to connect to the server. So here I'm creating a platform session. So this is where I'm connecting to the cloud, i.e. the data platform itself. And then I'm calling this get data method here for the first time with the variable set to true. So we get the ESG data and the streaming news. Okay, so that's the bulk of the actual market price data for the streaming and non-streaming code. And the remainder of the code is pretty much the Dash related code. So here's my main Dash framework code. So here I'm creating a Dash app. Now, I don't know if people are familiar with Dash or not, so I'll just give you a brief overview. I'm fairly new to this as well, so I'm going to give a very basic explanation. Essentially, the Dash framework offers a bunch of GUI components or UI components, and it works on an interval/callback basis. So you create your UI objects, and then you specify a bunch of callbacks, which can either be called on an interval-based basis or on an interaction basis. So when somebody clicks on a button or clicks a drop down or whatever, then you can call the callback as well. So we'll look at that in a moment. So here I'm just creating my drop down, which we saw at the top of the screen. Then my streaming graph, where I'm saying I need to animate the graph. I'm setting that to true. And then I'm actually setting an interval of once a second to actually animate the graph and update the actual stream. Then below that, I'm creating my Dash table for my streaming fields. In other words, the actual fields we had down here with the bid price and so on. Below that, I've got my news data table. So again, where I'm actually showing the actual incoming news stories. And I'm limiting that to 5 rows. So obviously I don't want to kind of fill the screen, so I've just shown the 5 most recent stories. As a new story adds, I add it to the top of the actual table. And then finally below that, I've got my ESG table, which is at the bottom of the, if you recall, was it at the actually bottom of the screen there. Now, because that's not updating in real time, I'm actually populating that with the data frame I got as part of my initial call here when we did the initial run, and just updating that once, or initializing that once, and that's it. Okay, so below that now we've got the actual callback. So essentially what happens is the framework is going to call this callback based on whether it intervals or any interaction that's happening on the screen. And we've defined the outputs here. So it's okay, so this callback is going to respond with the actual data for the graph, the data for the actual streaming fields, as well as the news data as well. And the inputs it's receiving are the actual drop-down value, or if it was fired by an interval, the actual interval that triggered the callback. So what do I have to do now here? Okay, when this thing gets called, the first thing I do is I check to see if the RIC has changed. So in other words, is this a interval-based callback, or is it actually because somebody's changed the RIC on the drop-down? So if the RIC is the same, then I'm going to take that to mean that it's just an interval-based. So I just want to update stuff that's on the screen already. I don't need to request a new instrument and so on. So all I'm doing there is I'm just popping the oldest tick on the actual tick list, and then using the streaming price object to call get snapshot for my mid-price field, and appending that onto the end of the actual tick list. So then the actual latest tick will appear on the right-hand side over here. Okay, otherwise, if somebody has changed the RIC, then I'm just saying get data. So I'm calling my main get data method again, this time with a new RIC and with a flag set to false. So what we'll do is we'll get the historical price for the new RIC and request a new streaming price request for the new RIC as well. Okay, so once that's done, regardless of whichever mode we're in, I'm going to get my latest streaming price fields by calling get snapshot. And I'm also going to get the latest news story by calling get snapshot on my streaming news object. What I'm doing then is I'm just checking the PNAT code to see if the news story has changed since the last time this callback was called. If the news story has changed, I'm just appending that to the top of my news history, so it appears at the top of the table. So we keep a history of the 5 most recent news stories. Then the next thing I'm doing is essentially creating my actual data, what I'm going to return to plot the chart. So I've got my tick list as a y-axis data, and just saying the mode of lines and markers. Then finally, I'm returning the data back to the Dash framework here now, which actually contains the data for the chart. along with some layout information, like I'm actually recalculating my range, the y-axis range constantly, because I don't want the actual chart dropping off if we had a static range. And then I'm just returning the streaming fields for the actual streaming data table, as well as my news history data frame as well, converted to a format which the Dash framework. So I'll send this back to the Dash framework. Dash framework will use this data to render the actual UI components here and to give you what you're seeing on screen here. Okay, so that, and I find all that remains then is actually to run the app. So we're saying on the Dash app, what we created up here, we're saying Dash app, run server, and that's it. Essentially, that, I think it's about 170 lines of code here, and that essentially gives you this relatively interesting Dash application. Okay, so that's the kind of summary of my Dash application. And before I move on to the matplotlib, is there anything you need to, survey-wise, or anything you need to do, Toby?
Thanks, Umer. Let's look at the results of our using WebSockets for real-time pricing. Then we'll ask another poll. Yes is 22%, no 38%, and don't use real-time data 38% as well. So, yeah, we have some people using and some people yet to adopt this standard. Interesting. The next question I'd like to ask everybody is, which web technologies are you currently using? And I'll pass that back to you, Umer, now, and we'll come back to the poll question in due course. Keep the questions coming on the Q&A. We're looking to update you all with answers in real time as much as we can as we go through the presentation. Back to you, Umer.
Thank you. Okay, so as well as the Dash framework, I had noticed that the matplotlib is also one of the more popular libraries out there for creating plots and charts and so on. Indeed, when I did my the previously mentioned articles on the technical analysis and volatility surfaces and so on, I actually used matplotlib. But for that, I was just creating static charts, so I didn't really need or have the need to try any streaming charts. So at the time, I just assumed that it was going to be a fairly simple matter of just somehow injecting data into the plot object or subplot, and somehow it was just going to, update the chart, as and when I wanted. But I was quite surprised when I looked into it as I was researching it for this presentation, and I realized I actually had to animate the chart, for want of a better term. Actually, the method is called animate, So I'm going to show you a simple example of plotting a chart using matplotlib, where I'm just going to plot the bid and ask values, which are updated every, I think, 300 milliseconds or so. So I'm just going to run my little example, then we'll look at the source code afterwards. Give that a few seconds to start up. Okay, so again, it's a fairly simple, straightforward matplotlib example here. All I'm doing is I'm subscribing streaming price to the Euro USD RIC, and then I'm plotting the bid and ask values. Now I'm doing something similar to the Dash example in that when the application starts up, I get historical tick data for the record. I think in this case, I just get 100 ticks, so I can backfill the actual chart and show you the past 100 tick history. The only different thing I'm doing here is that I'm not plotting every single tick that comes in. I actually check to see if the bid, every time I get an update from the server, or actually within the actual, you'll see the interval-based thing with the matplotlib as well, I actually check to see if the bid or ask value has changed or not. If either of them has changed, then I'll update the chart. Otherwise, I'll leave the chart alone, and just so then you don't see me too many flat lines. You'll see it looks slightly more animated in terms of more ups and downs and so on. Okay, so I mean that's fairly simple. There's much more I can tell you about that. So we'll just go and have a look at the code for that.
Let's just pause for the answer to which web technology you're currently using. Java servlets, JSP, sort of 11.5%, ASP.NET, which one of the questions we had earlier was around ASP.NET, nearly 10%. Node.js, 21%. CGI scripts, nobody. And other, 57%. So maybe interesting to delve into that a little bit. Back to you, Umer. Oh, no, let me just ask the next poll question so we make sure we're getting that. What's your main programming language? And I will pause there and back to you, Umer, and we'll come back to that poll question in due course.
Okay, thank you, Toby. So this is, again, a fairly simple example. I'm just pulling in my libraries here, matplotlib libraries, my data platform library. And then once again, I'm creating a platform session. So I'm connecting to the cloud again on this occasion. And then I've got my RIC, my number of ticks I want. And once again, I'm using the function layer of the RDP library to get my historical price events, the bid and ask field for the euro, and just getting 100 ticks this time. So I got my bid list and the ask list. And then all I'm doing is essentially using data frame, the bid and ask values there. I'm just reversing them once again so that the latest tick up is on the right-hand side. So that's to backfill the chart so we can actually look at the previous ticks on the chart. Then I just create my streaming price request again for the RIC with the fields bid and ask, and then I open up the streaming price request. That sends us a request off to the server, and then the library should start receiving the updates back and it'll start caching them behind the scenes for me to dip into. Before I show you the animate function, in terms of the actual rest of the code for the application, all I'm doing is creating my canvas, setting the title, and then I'm using the func animation method of the matplotlib library to specify my animate function. And I'm setting the interval to 300 milliseconds. I want it to check and potentially update the chart every 300 milliseconds. Okay, and then I'm just saying show the chart. Okay, so this is the actual animate method, which gets called once every 300 milliseconds. Now, once again, I'm snapping the bid and ask value, but whereas before with the dash streaming example, I was calling the get snapshot method. With this one, I'm actually using the streaming prices object itself and just specifying the RIC and the fields I'm interested in to extract the individual fields from the particular instrument. So that's another way of using the streaming price. Again, it's fairly flexible. There's a different way of doing things. So there's another way. I just want to demonstrate how you can actually get the bid and ask values. So remember, these devices are being cached behind the scenes by the library, so you can dip in when you want, do a snapshot, and get the latest values in real time, as they're kind of being stored by the library behind the scenes. Okay, now what I'm doing is I'm actually checking if the latest bid value is different to the previous most recent bid value we had, or if the ask value is different. If either the values have changed, then I'm popping the oldest values off the chart because I want to limit it to 100 ticks, and then appending the latest price, the bid and ask values onto the list, and setting my report flag to true. And then again, once again, on this example, I'm calculating the X and Y axis dynamically as well, because otherwise I noticed that for some volatile instruments, they kind of went off if I use a static Y axis, they kind of went off the chart. So again, I'm just simply doing the Y and upper and lower range for the Y axis. I'm plotting the Y line, the bid and the ask list, sorry. I'm setting the title, and that's it. And that is essentially the code. I think we've got 60, 70 lines of code there for creating the streaming plotlib example there. Okay, so that's that.
Thanks, Umer. Let's just see the answer to the main programming language. We've got Java around 10%, C++ 7%, C# 18%, Python over 50%, 51%, JavaScript 14%. So very interesting. The next poll we'd like to ask is, what environments and frameworks do you use for app creation? And on that, we'll come back to that in due course. Back to you, Gurpreet. I think you had a question for Umer.
Yeah, so both the examples that we saw right now, they showed polling the market data, but market data could be event-driven. So is there a way to handle that?
Yep. Yeah. So I found this is what I found with the Dash framework and the matplotlib. It seems that the framework themselves control how often, or when you can update the actual components. However, when I was looking around, I noticed the IPy widgets, which is another fairly popular visualization library, actually lets you update the framework, the actual components, the GUI components, as and when you want to, rather than it dictating the interval or interaction-based thing. So I've done in my next example using IPy widgets, and more specifically IPy sheet. I also, when I was looking around, I got the impression, I didn't look into too deeply, but it looked like the bokeh and the hollow views, two of the frameworks that seem to be, fairly popular, may also offer a similar facility where you can actually inject data at the time of your choosing rather than on a particular interval-based basis. So I'll get on with this particular IPy widgets example. And what I'm going to do here is now I'm actually going to use the event-driven mode of the streaming price object, so I can update the actual component when I receive an update from the server, as opposed to doing it on a fixed interval. So we'll just get the, I'll run the example first, and we'll look at the source code. But before I do that, quick thing I just want to mention before I forget, if you look at one of the first early lines of the code here, I'm actually creating a desktop session in this particular instance. So I'm actually connecting to, I've got an instance of the Refinitiv Workspace application, which is our desktop application running on my desktop. So I'm targeting that here. I could, however, if I wanted to, replace that line of code with this line of code, which is the open platform session, and connect to the cloud instead and source the same data from the cloud. But for this example, I thought I'd use a desktop just for a bit of variety. Okay, so let's just run this, get this running. Just wait for a moment for it to catch up. I'll just have a bit of water. I think we're going to have a technical hitch here. Okay, so let me try and. Seems to have got
Whilst you do
stuck.
that, let me just look at the answer to the questions. We asked what environments and frameworks to use for application. Mark Migrom has pointed out that should really be a multiple choice question. Good spot. We'll look at that for the future. So apologies if you're using multiples and won't be able to tell us about that, which will, of course, impact maybe the answers. But let's have a look. We've got a Python dash panel, and voila, it's 41% approximately, 31.5 for Angular Node, R and Shiny 3.7. So there's a spread across all of these technologies aside from Kotlin, C++ 7%, Java, Spring, etc. 11%, and .NET 5%. And so before we move on, let's just poll you again whilst Umer has a look at what's happening on his side. If you're using Python, are you a full-time developer using Python to help with your main job function, so a citizen developer or Banco codes, fin coder, or that doesn't apply to you? How are we looking your side, Umer?
Yeah, we seem to be having a technical hitch here for some reason. My my Jupyter notebook seems to be stuck. I've tried stopping and starting it. It's not even getting as far as opening a desktop session. Interesting. Okay, let me just try stopping and starting that one more time. Okay,
whilst you do that, let's give about 30 seconds. We've given some opportunity for people to come back on that poll. So let's just see where we are with whether people are using Python. So full-time developers, nearly 16%, 50%, which is really interesting, using Python to help with main job function. That very much fits in with our line of thinking and strategy. So great to see that validated and not applicable to around 34% of the people who answered. Let's, whilst you continue that, Umer, let's ask the next question. There's a couple of questions coming in on whether these code samples will be made available on the Q&A. Yeah, absolutely. The code samples will be made available both in Git, and they will be sent out to everyone who has registered and attended, and just those who registered and was not able to attend post the event today. So that is in good shape. You'll be able to get access to that. Umer, how's that looking?
Yeah, so we're fine. I think I need another restart of my Jupyter notebook. I think I've probably been running it running all day long. So, okay, so what I've done, again, I've kept the example fairly simple because the thing I want to demonstrate is how you can use the event-driven mode as opposed to, doing all songing, all dancing, widgets example. So I've got a fairly straightforward example here. Got a drop-down list again with some instruments in there. So, oops, that's the accordion. Okay, so I'm just going to go ahead and actually select these and click add, which is now going to connect to the server. Okay, so what we've got, that essentially sent the request off to the server, which, well, is actually gone. The request has gone to the actual desktop instance of the workspace I'm running here, and the value should be coming in real time here. So I'm going to add another instrument. So let's add the Japanese yen. We'll add the euro as well. Okay, so essentially I've sent these requests off to my icon, my Refinitiv workspace. I'm getting ticks coming in. As you can see, we've got the some of the fields ticking here. They're coming back in real time. And there's probably not much more I can show you there. The other thing I should point out here is I've got a little status label here, which just indicates the status of the particular instrument, the last instrument I requested. And for those who are not familiar with the streaming price data, essentially the server can send you a status message. Normally it sends you all is well when you first request an instrument. If, say, something happens, say if the exchange indicates there's a problem with some data, if it's suspect or stale, the server may send you a suspect message to indicate there's possibly a quality problem with the data. So you may want to use that to inform your user that the data's suspect, just be aware kind of thing. So I've got a little status table here. I mentioned that because I'm going to refer to that again in the code in a moment. So that's the simple GUI there, which is updating in real time as ticks arrive from the server as opposed to on an interval-based basis. So let's go ahead and actually look at the code for that. So the way I triggered it, if you remember, is when I clicked the add button, I started subscribing to a RIC. So let's go and have a look at the my add RIC method. So what I'm doing is when somebody clicks the add button, I'm pulling out the actual RIC that was in the drop drop-down. I put it into my list of RICs I'm subscribing to, because obviously we've got multiple RICs we can subscribe to down here. And then I'm using the streaming prices object as I've used previously in my other examples. But in this instance, I'm passing in my list of universe of RICs and fields. However, this time I'm actually specifying some Lambda functions, my event handlers or callback handlers, depending which language you're familiar with, to say, okay, when so-and-so thing happens, when such an event happens, I want you to call this method. Now, the first method I'm using, or the first Lambda function I've got, is the onComplete event. So essentially, the onComplete event is part of the streaming prices library, and that is that when you request multiple instruments, when the server sends back the initial response to every single one of those instruments, the first time you request them, the onComplete method will get triggered, or the event will get triggered, and then I'm going to call the create tick table so I can populate this full table. Likewise, I've got an onUpdate method. So when any one of the particular instruments or one of the fields in one of the instruments is updated and the server sends an update to the library, the onUpdate method will get triggered, and then we'll call the update tick table. And then finally, if we get a status message from the server, the initial one, or if there's a problem with the data, then I'm going to call the display status method asynchronously, on an event-driven basis, if that happens. Okay, then I'm just calling streaming prices open. That'll send my request off to the server, and the API can start receiving the refreshes and updates from the server, and then call the appropriate Lambda function. So let's go and have a look at some of these functions. So we've got the create tick table. So all I'm doing there is I'm actually getting a snapshot of my particular instruments, as and when it happens, to get a list of all my instruments and all their values, pulling out the field names and a list of all my RICs. Then I'm using that to create a data frame indexed on the RICs, and then the columns being the field names. Then I'm iterating through the RICs and then just populating the actual data frame with the RIC name and the field name to get the value to transfer that into an actual the data frame itself. Then I'm just using the IPy sheet from data frame method to convert the data frame to an actual IPy sheet object, a ticks table, I'm calling it. And then I'm passing that to the IPy widgets, a table widget object, specifying the ticks table and the table header as children. What should then happen is you then get this thing displayed here for the first time, with the displaying the actual column headings, RIC names, and so on. Okay, so that's the first time. Each time if somebody adds a new instrument, we do a streaming price request, the create tick table gets called, so it creates that whole table. After that, again, as Gurpreet pointed out, things update asynchronously on an event-driven basis as and when there's market activity. So what should happen then is, as and when any RIC updates and one or more fields for that RIC updates, the onUpdate Lambda function should get triggered, and then the update tick table function gets called. So once again, we've got the streaming prices object, and it tells you which RIC was updated and the fields that were updated. So all I'm doing is I'm going through the list of fields, getting the field name and the field value, and updating my existing data frame that we created earlier for that particular RIC and those particular fields. It could just be one field that's been updated, or multiple fields, perhaps like bid and bid size, for example. And again, I'm using the IPy sheet method to convert that data frame to my IPy sheet. Once again, attaching that to the widget as the IPy widget as children, and that should render update the actual table. And as you can see, you'll see individual fields ticking because we're receiving updates for those as and when we're getting the updates from the server. And finally, we had the onStatus handler as well. So we've got display status. All we're doing there is something you should do if you're writing that GUI application as well. If you get a status message from the server, all I'm doing is I'm just formatting it with a RIC and a status name, and then using that value to update this actual label down here to keep the user informed, in case there's any issues with the data and so on. So that pretty much, there's a little bit of code here, I think, which just covers IPy sheet and IPy widget stuff, which I'm not really going to go into because I'm sure you can look into that in your own time when we share this code, on GitHub. Okay, thank you very much.
Thanks, Umer. We had another question out there as well. So from what you've seen, do the Refinitiv data platform libraries make it much easier to implement your real-time streaming data needs? I'll pause and let the audience come to that. Interesting question from Attila here, which was what would be a learning track for citizen developers? One of the things we're really aiming for here, and I hope that we've been able to demonstrate today, is the ability to hit a layer within the platform which is appropriate for where you are today. So if that's if you're a business coder, fin coder, citizen developer, that may well be the function layer, which is really as straightforward as ek get data, rich fields, parameters, if it's history, type, start date, end date. Very, very straightforward to use. I would argue as straightforward as using Excel functions are today. And of course, you then have the other layers if you're more experienced and want to have more control and unpack payloads, or if you just want to hit at the sort of transport layer, and even deeper layer than that, if you're sort of looking for really high throughput and low latency streaming, then we cater for that as well. I would just say we are next week launching a brand new integrated Python development environment, which will take this to the next level for us. We are actually running one of the series of these webinars is on that. It's called Codebook. I won't give too much away today, but I'd really encourage you to dial into these next webinars. It's really, really exciting. It will enable you to really take the desktop experience to the next level. And on that, Oscar's asking, will we get a copy of the files? Absolutely. So rest assured, we will be sending you all links to GitHub and anything else, other resources which would be applicable for this post the event. So without further ado, let's just move on to that final question, which was great to see a mostly resounding yes. A small amount say no. Let's hope they're the people who are not dealing with streaming data today. And an unsure 40%. I know there's lots to discover, lots of new things we covered here. I'd just like to thank Umer and Gurpreet for these great presentations. Thank you very, very much for this. I'd encourage you all, if you're not members today, to have a look at developers.refinitiv.com. There's a fantastic set of tutorials on there, samples, videos, articles, both from the technical through to the modern portfolio theory. How do I trigger a chatbot to trigger when my technical analysis crosses or gives me a trading signal. So please do have a look at that. I think you'll find some really interesting things there. Umer, Gurpreet, any final words from you?
No, just to echo what you said, please, come to the portal, have a look, and there's loads of, free tutorials, videos, examples there, especially if you want to try and learn, start with some basic Python, then look at some of the, great video tutorials we've got with, Icon, and then, move on to the RDP library as well. Yeah, definitely.
Yeah. Fantastic. And we tried answering the questions that have been asked, and we might have missed some of them, but there's a Q&A forum in the developers portal as well. So feel free to post a question there and we'll pick it up and answer there.
That's a good shout. Thank you. Thank you, everybody, for dialing in. I hope these are resonating with you. We're really trying to make these interactive and answer your questions as we go along. We've moved from pre-recorded webinars of last year, and I think much more appropriate for us to be much more engaging given the current climate. I hope you've enjoyed today's session. Please go to the dev portal, look at the sessions coming up. We'll be posting about them on LinkedIn and other social, and the recording of this session will be available to you and linked to in the emails you'll receive after this session. So again, just finally, thank you from us, and we look forward to hosting you on the next Refinitiv Developer webinar series. So moderator, if you could close the call now. Thanks, everybody.
Thank you.